You are listening to the songs of humpback whales. Their songs play a critical role in the story we are about to tell. It is the story of the invention of the Wave Glider, a totally new ocean-going robot. It is a strange and wonderful story. And it all began here in Puako, a community on the north shore of the Big Island of Hawaii, at the home of Joe Rizzi.
We're sitting out in front of my house, and this object in front of you has become infamous. It's a stump. It's become the meeting place. When you look at this island, it's really very, very water-centric. What I found is the more time I spent in the water, the more I liked it. The thing that changed it, perhaps without me knowing it, was the whales.
You hear this sound, it's just this explosive breath. The vapor just comes and blows onto your face. This humongous animal comes rolling out of the water gracefully, gently, without a splash, and out of nowhere can heave its 40-ton massive body completely out of the water and flipping over and landing back in the water on its back, as if to say, whoa, isn't it great to be a part of this world?
You don't have to go down very far underwater to hear the whales. You don't need hydrophones and microphones and a lot of electronics to hear a whale.
When you get to be on a canoe like ours and they come up in between your hulls and they start to sing, you cannot help but understand that there's something greater than yourself that these whales are, and that just being amongst them is a privilege.
I've been with whales where I would get in the water with a singer at the surface and he's already starting, and then he would just roll right in front of me and continue singing as he's in motion, and then he would just stop. And when you're that close to a singer, your whole body is enveloped in sound. Your air spaces are vibrating. It consumes you. It takes you over.
These are males that are singing this series of sounds, which we call their song. Inevitably, a singer will sing until another lone adult shows up and comes over and joins the singer. And at that point, the singing stops. And we have learned that that lone adult is another male. And there's, a network being created there. The question is, why?
Joe had been listening to the whales off of his backyard. He'd become interested in whales because there they were in his backyard, and he decided, gee, if I wanted, I could just drop a hydrophone and I could wire this to my house, and I'd turn on the stereo and here would be the whales, and he actually did that.
I don't think the best way to create something new is to be looking over your shoulder and figuring out what you can do with it. I think you want to focus on learning something about what's new and seeing what's there. It's a process of discovery without necessarily having a purpose beyond discovery.
How did Joe put it to me? First of all, the job description was he was looking for someone that was good at tinkering. And if I were to do that and have fun, he assumed some good would come from it.
Tinkering. The idea, to me, it's just an idea of, it's another word for playing. I liked electronic things, I like computer things, I like the whole process of creating something from nothing. And to do that, you go down a lot of paths that don't go anywhere.
Joe is a very inquisitive guy. I mean, he never stops trying to figure stuff out. You know, he's tireless in his desire to understand systems and how systems interact and how people interact, and he's really quite a master in all of that.
I think most of them you consider to be engineers of one form or the other, right? Engineers come hackers.
And you're an engineer.
By training and by profession. Right?
And a hacker?
What? Yeah.
Is that just...
Hacking is, you know, we consider to be experimenters, right?
It was in the very, very earliest times when we didn't have any website or anything. We just had a wireless radio transmitter, and we would send the signal back, and we would listen to it on a receiver. I thought it would be interesting just to make that sound available in this little general store. When I mentioned it to Narand, he immediately thought, hey, what a great idea that is, and we went and put an antenna up on his roof and built a little box to put the receiver in and gave him a couple of speakers, and the next thing you know, we had live whale sounds.
We have tons and tons of people from the island and around the world who come and visit. They come and stop by the store to come and listen to the whales.
So we built our first durable piece of equipment that could last out in the water. We had a lot of abortive attempts. We'd build something, we'd put it out in the water, it would sink, or we'd build something and water got into the electronics, and you know.
We swam out with this Jehu and put it in the water, put a little small anchor on the seafloor, and sat there, and it was beautiful. The sun was, you know, low in the sky, and water was calm, and we're just swimming with it out there. Then the damn thing sinks.
It's almost like the early NASA rocket ships, when before we knew how to build a rocket ship, they'd, you know, get 10 feet off the pad and they'd blow up, or they'd turn around and nose in. We finally built our first durable system that had a little motorcycle battery in it and some electronics that we set up. And we anchored it in 40 feet of water with a hydrophone dangling down. We heard whales, but we also had a background sound that sounded just like somebody was frying bacon, or it sounded like you were tuning into whales on a shortwave radio that had nothing but static. Somebody mentioned that it might be snapping shrimp, and I never heard of that. I had no idea what that was. And we knew that from reading that if you go far enough out off the coastline, the sound starts diminishing.
And we took kayaks out on a good day and hung hydrophones in the water, and we kept going out further and further until we just physically went out until we could hear no more snapping shrimp.
And so we did a makeshift anchor out there, and we're really happy to be hearing the kind of sounds we wanted.
I mean, at that point, we thought this was going to be easy.
But the whales come in the wintertime. And whereas here in Hawaii in the summertime, the water is frequently just like a lake. But in the wintertime, you get a lot of storms. And we put on tracking systems, or we'd put our name and phone number on it, and somebody would find the thing over on the other side of Maui and call us up. And we started asking ourselves the question, well, what can we do about making it easier to keep these buoys moored a mile offshore? And eventually asked ourselves the question, well, how could we build a buoy that would stay in place that didn't need an anchor? How do you do that?
Joe and the Jupiter guys had, recognized that if they were going to have something that stayed out in the ocean and it wasn't going to have an anchor, that it needed to have energy from somewhere. And so it was how to do that.
One thing led to another, and along the way, Joe was collecting other similarly curious electronicers, and they all started brainstorming, often over gin and tonics, and trying to figure out a better way than a bigger anchor and a stronger anchor cable. And they came up with the idea that they needed to design a vehicle
that somehow would hold station wherever they wanted it.
We would work, my wife would say, when are you guys coming home? What are you doing? You've been doing this all day. And we'd work to 8, 10 o'clock at night, putzing.
Joe had this idea that he would have a remote-controlled boat that would follow the whales around and listen to them. And for me, it's like this whole thing was brand new. I mean, it's like, well, that sounds really interesting to me. So the idea was to use this automatic position reporting capability on this boat.
I called up a longtime friend of mine who has a son who I'd also known for many years, and I posed the problem to them.
He and I both could draw, which I think is good for mechanical engineers. You can think in 3 dimensions and 4 dimensions with motions and stuff. He's very good at that kind of thing. I knew he would be interested in this, and that is going to be a hobby thing. And it was sort of a hobby thing for Joe. And so, anyway, Roger got really interested, and by the time we came back from our vacation, he'd built a bunch of little models that you could put in a pool, make waves, and they swam.
Roger incredibly quickly conceptualized this scheme of directly converting the energy of a wave into motion. And he made a bunch of sketches showing a way that might work.
Actually, first it was going to be flapping arms like this that were going to generate electricity. And I had a drawing that looked like a torpedo with flapping arms. It looked like a bird, but when I drew it, I wasn't thinking it was a bird. I was thinking those arms were actually just for coupling the vertical motion into a generator. So it was actually this flapping mechanism of arms moving up and down like a bird that preceded these other ideas.
It was a remarkable insight, and that I thought we really could do it, and we want to jump on this thing quickly and take the next step, which we did.
It was this guy was the first thing that I built and I put it's missing a nail. There was a nail attached to it that made it heavy. And I put this down in my bathtub and just, lowered it and raised it and lowered it and raised it, and it would swim along. And it was really simple, but it was sort of, that's it.
Roger got a fish tank and had a 2-inch model of a device that he thought could run on wave power. I can clearly remember our little group at that time. We probably had 4 or 5 of us watching a fish tank with a motor on a track getting towed by this little airplane wing. And it was a really interesting moment in time that will be tattooed on my brain for forever. Because we all looked at that and realized, well, we can just go out and build one.
Roger is absolutely going to be able to go from this little 3-inch thing in a fish tank to a real one in the water.
Yeah.
And because I felt that the invention had already been made.
I thought toy first. And then we had the conversation at the stump. And the stump is a place of ideas. And of course, we're talking all about the different possibilities of what this technology can do. And it started to sink in that this is real.
All right, ready, set, go.
Let's make waves from
We need a few more waves now.
Let's make waves for this end.
We took turns, Bill Stutz and I, making waves with a 5-gallon bucket. And so these waves would go, and lo and behold, the thing was going around in a circle.
It's turning the other way.
No, it was always arcing to the left.
I think he saw me running around the pool because it would swim in a straight line and hit the side and going back and forth, and he said, can we make a rudder for it? I can go get some tinfoil, let's make a rudder. I didn't like the idea of the tinfoil rudder, but I knew that the plastic that it was made out of, styrene, I could just bend it.
The thing was in the pool, and we're off to the side of the pool chatting about, well, this is very interesting. What else could we do? How would we control it? And I honestly don't remember which one of us, but we kind of collectively looked over at the pool, and the wind was blowing, and there were little waves about 1 inch tall.
Everybody got real quiet, and everybody just sat there and watched it.
It gets a lot of movement out of a very small wave.
Yeah.
And the darn thing was going around in circles. And we stopped, looked at each other, and it was one of those holy cow moments.
Boy, it really moves.
It didn't take a lot of imagination to figure out, well, I guess we can have microprocessors and GPSs and whatever else you want and steer it.
Dad's in the back with a belt sander, shaping floats, fiberglassing floats. I'm putting the systems together and trying to make sure they're not going to sink. We're calibrating compasses out in our makeshift compass calibration tool.
We started keeping notes on the designs and started thinking about filing a patent for it and so forth. We were building little structures, putting it in the real water, surfboards with cables connected to it with a engine structure that was going to be 10 or 20 feet under it. And we ended up with something that had a wing modeled after a whale's tail. I got an interesting photograph of it sitting on the lawn here before it went in the water, and it just sort of looked like a nice engineering experiment for something, but it kind of looked a mess. And then we put it in the water. This is an example of this ugly-looking mechanical assemblage. You throw it in the water and it looked like it just came to life.
I got to swim with this, so as the float goes up and down, it pulls on the wings, and the wings underwater would move with such great fluidity and grace, and they seemed alive.
And so a couple of things were interesting. One is the direction of the motion was completely independent of the direction of the wave. So that all the wave had to do is move that surfboard up and down. And it didn't make any difference what the direction of the wave was, including coming right at you. It would go into the waves as well as it would go with the waves. It would go orthogonal to the waves. It didn't make any difference at all.
Look at that. Even in a small sea like this, which is like, a 1 foot swell, it doesn't take, it's gone.
But the umbilical was the toughest thing. It's got to connect this float, which is at the top, to the glider, which needs to be down, some distance to get below the large waves.
You put it out there, and a few days later, in the middle of the night, you get an alarm. Sub's not talking to the float because the wires are busted.
You get a 10-foot wave, and you can get thousands of pounds of force. And there are all kinds of electrical wires embedded in that. And I think everyone to a person said that it will never survive.
I mean, the first mission that we ever sent it on, we turned it loose somewhere in front of the house here, and we sent it on a path. You can see over to the right there on the far side the Hapuna Prince Hotel, and we gave it a course to go from the front of the house here out in the water and arc around and land on the beach at Hapuna.
So what we did was we set up a waypoint, which is a GPS coordinate that we tell the robot, here's one, and here's one, actually on land.
You turn loose of your baby, you're not there watching it, you're sending it out in the deep blue sea all on its own. It's the first time. Something goes wrong, we weren't there to, do anything.
And so we send it these little commands, and we all grab our beach chairs, and we pile up in the back of the truck, and we get our little coolers, and we all go plunk down on the beach, and we're sitting there, and we're all taking odds and bets, what time it's going to get here, and was it going to drift, or the current going to take it. And it comes into the beach. It comes, and we see it coming, 500 meters, 300 meters, 200 meters, 100 meters. But, okay, we got to go get it. We all just went, whoa, we can send this thing places. We can do things with this. We can put sensors on this, and we can tell it to go anywhere we want. That was like, wow.
I think the first time when I saw the wave glider and when we were introduced to it, literally I got this big grin on my face because I thought to myself, finally someone has paid attention to what the environment naturally does, that is interacting with it in a way that's it's not invasive at all, but it's working with the ocean. that it utilizes the energy from the ocean. I thought, this is the greatest thing in the world.
We relatively quickly got to a point where we did have an autonomous vehicle and had to apply for a permit. They didn't have any category for it. And eventually decided its classification was marine debris. And so we got a permit kind of based on that. Certainly, from that point forward, I felt it had a life of its own, and it went from there to more work to improve it, and so forth and so on, and realizations that it may have a diversity of applications, to then founding Liquid Robotics.
You're addressing needs that don't really have a market yet. That means that the risks are larger, the road might be longer to get there, but the rewards could be a lot greater. And I think that's something that Joe really had a much better sense of than anybody else maybe in the world, of the potential benefits of being a market creator versus doing what other people have done. So the fact that the applications and the use cases for the Waveglider weren't necessarily exact parallels to what people were already spending their money on didn't deter Joe.
One of the ways we thought that made a difference was we weren't predisposed or biased by the common knowledge of maritime systems. None of us had any background that told us this thing will never work. We all had background being from Silicon Valley, inventing things that weren't supposed to work, and creating new technology that hadn't been thought of before.
But see, that's the magic about this invention. I mean, it's what I call a greenfield discovery, in the sense that when Jupiter / Liquid Robotics applied for patents on the Waveglider, there was nothing. There was no prior art. So you would think that something that there's no prior art, it will take somebody 5 hours or 10 hours to explain to you why this technology is new or why it works. I think for the Waveglider, it takes all of 30 seconds.
Testing the waters with the robot. Today, BP deployed a new device to monitor water quality in response to the Gulf oil spill.
The Waveglider is already at a state where we can take it and put it to use in the water. It'll stay put for a couple of years. We can put electronic systems on it. I can see Jupiter focusing on the non-commercial applications for this Waveglider.
He wants Jupiter to be the core nonprofit group that brings great think tanks together and curious minds together. And trip, stagger, fall, we might come across something that's really interesting.
To decouple the process of discovery from a milestone chart has immense value to the process of discovery. That is really an art form. Science and discovery, to me, is an art form.
Jupiter has operations in 2 locations: Los Altos Hills, California, and Puako, Hawaii. This is the Jupiter Hawaii team, headed up by Beth Goodwin and her colleagues, Mark Brandoni, also a captain, and Murray Taylor, an electronic systems professional.
You 2 guys will be doing the scuba, Dave here will be doing the surface diver, and you'll be deck support.
Can anybody think of any reason why those GPS locations wouldn't be right smack dab over that intermediate float?
It's all within a circle, and we did that several times, but sometimes that could be what's happened to it. Anyway, we're just going to have to go out and give it another shot today.
I agree.
Beth Goodwin worked for almost a year to design and build this Jupiter research vessel, the Mei Maru. Maru is a Japanese name given to many vessels, and it means to come back to a safe harbor.
This is going to be fun.
Hawaii is the perfect environment, as it has warm, crystal clear water and is one of the humpback's winter breeding grounds.
We have these squares, we call these operational polygons, and what we have is through the GPS the glider knows where it is, and if it goes outside of this it'll send us an alarm.
That alarm right there, BB out of bounds. Comes to about 10, 20 people. We all got alarmed.
A couple of years ago, we had a Navy SEAL out here getting ready to do a little snorkel with us, and he was suiting up, and he said, "You always want to make sure that when you go swimming in these waters, that you have a knife with you, and in case you see a shark, you can stab your buddy." Okay, so these are Naupaka leaves. They grow all along the coast, right on the water. They're happy in saltwater environment. And some people's spit is no good. Usually you just spit in your mask to keep it from fogging. And some people's spit doesn't work too well, including mine. So I grabbed some of these Naupaka leaves, which we heard from local folks. And you crunch them up in your hand and you rub it on the inside of your mask, and it has a little oil, and it just absolutely stops the mask from fogging up. Terrific stuff. Somebody ought to bottle it.
We can hold it. Homeward bound?
Homeward bound.
So this is our WGMS. This is our user interface page. And I'm going to set it to 4 hours and resubmit. And it's these little red, or little breadcrumbs of where it's been the last 4 hours.
Oh, I see. So, and this is the one that's out there now, broadcasting or transmitting or whatever.
Yeah,
you call
that's
it.
transmitting.
Okay.
And so I want to see in nautical miles how far this box is. And it's 10.4 nautical miles from the cell tower.
You've got the ability to sit back in a comfortable lazy boy with your laptop open on your lap and run a fleet of robots in the middle of the ocean. But the tool to do that is really very complex. It's got a lot of moving parts. It's a control system because it has to actually operate the robot. It's got to communicate via satellite back to shore, and from the satellite systems that are on shore onto the internet, and from the internet to our servers. And then our servers have to serve up this web page with a useful interface. And the interface needs to be such that you can see multiple wave gliders, figure out where they are in relation to each other, where they are in relation to everything else in the ocean, from buoys to high current zones to other ships, and direct those wave gliders. And it's automated robotic intelligence. You know, what happens if a ship's headed your way?
Mm.
The software takes care of it.
Even though in principle it's really simple, in practice it took a lot of work, and we're still not done, and that's why in fact I haven't done much with the microscope. There's this view that cholera is actually distributed around the world in ocean currents on the backs of a small organism called a copepod. I figured that it might have some benefit if you could swim this thing off of river effluents in parts of the world and pick up streams of copepods and infer from that you may have cholera. In fact, probably, I think the people that think that's how it's transmitted would say you don't even need to find the cholera. If you find copepods, there's cholera there.
So this is a real-time display of electrical signals coming from slime molds, right? And the top pane is just the real-time voltages, right?
Slime mold has got very, very bad PR, starting with the name. I mean, if you were going to try to promote slime mold, the first thing you'd tell them is they got to come up with another name. Make it something more showbiz.
Are they producing electricity?
Yeah, so the slime molds are producing these voltages. We're measuring them directly just like we would measure your brainwave.
So this is the third buoy head, 20-watt solar panel. This tube houses the electronics. It's a single, actually it's a double board. Cellular antenna out here. There's a heat shield like this on the front with a flashing light for the marine requirements and a flag. And then these holes were originally for mounting a Canon G10 camera.
There are other phenomena that we're exploring at nighttime, almost like somebody flips a switch. About an hour after sundown, a very, very loud hiss comes up. The sounds you're hearing right now, if you listen to it, they're pretty clear, not much background noise. What happens shortly after the sun goes down is you're going to hear this nice, clean, clear sound in the background rise up greatly and rise up to a point where it sounds like a very, very loud hiss that's underneath the sounds of the whale.
Okay, I want you to hear this. We're starting to hear the hissing. It's going to get louder and louder. Take a listen here.
It may turn out that this background noise has got a life of its own, and the science behind whatever is going on could turn out to be interesting. In any case, this is a problem that we may not be able to solve. This problem may not have some solution, but it's going to be worth understanding.
At the ocean now, and it's very infinite. There's so much possibility, and I think sometimes we speculate. You know, with all the data that's out there now, we speculate. But you have this possibility that can be at any given place, at any given time, for any length of time, no matter what the condition of the ocean is, to really, truly bring back static data that can be utilized.
We could put up enough satellites, or we could put out enough ships and so forth to collect all this data, but the economics don't work. And so what's very, very special about the Wave Glider is that economically, it's a means by which the average guy, the average researcher, the average nation has the ability to collect this kind of data and do the things with that data that they need to do.
In the future, we're going to have bigger wave gliders. And bigger wave gliders, it will be more imperative that they make faster, smarter decisions. And then we'd like to see them be able to work cooperatively in swarms to achieve tasks. And so when you want to know about El Nino, which is a huge, huge problem, you could have them, you know, oh, I found this, have you found that? You know, talking to each other and then making decisions to move into areas.
I really don't see how it's not going to turn out that there's, you know, millions of these things covering the oceans, doing all kinds of different things. They may look quite a bit different from the ones we've seen today, but I think that we need to understand what's happening in the ocean for a lot of reasons, a lot better than we do right now, and that you can very cost effectively position unmanned systems, wave gliders. I think that the wave gliders will evolve like airplanes evolved, and probably 50 years from now there will be different designs. Hopefully the fundamentals will be understood a lot better, but we're still, I think, closer to the beginning than the end of the evolution of the wave glider.